Hi, my name is Ian Fogarty, and I'd like to talk to you today about alkenes. Alkenes have a carbon double bond in them. They get the ending of ene. They have bond angles of 120 degrees. They're flat. There's something called unsaturated, and they have sp2 hybridization. And here's kind of a general formula for alkenes with a carbon double bond. You notice that the carbon right here has 4 bonds, as it always does, but now it's 2 of them are 2 carbon. On the left you have a ethane, and on the right you have an ethene. Let's focus on the left-hand molecule for a moment. You have a CH3 and another CH3, and notice how the hydrogens are sticking up and down and left and right. They have some three-dimensionality to it. Those bond angles are 109.5, and they're sp3 hybridized. On the molecule on the right, we have an alkene, an ethene, and so those bond angles are 120 degrees, they're flat, and they are sp2 hybridized. And notice how when they rotate, you'll be able to see the three-dimensionality and the flatness. Here's a good freeze frame of an alkane and an alkene. The alkene is in front, and you can see how it's flat. Bond angles are 120 degrees. It's sp2 hybridized. In the back, you have the alkane, and those bond angles are 109.5 again. Notice how on the front carbon, you have hydrogens that kind of go to the left and right and up, and then one that's straight down. And in the back carbon, you have 2 that kind of go down and to the left and the right, and then one that goes straight up. And so these hydrogens are called staggered when they're in this configuration. So unsaturation is a situation where there's not enough single bonds as compared to the saturated ethane. So here's an ethane right here. There's a carbon and a carbon. It's got my 3 hydrogens, and this carbon has 3 hydrogens and 1 bond between them for the 4 bonds each. In order to make the carbon double bond over here, I have to remove this hydrogen, and I have to remove that hydrogen in order to create that double bond. So there's 2 hydrogens that are missing in order to create this double bond. And so we call that 1 degree of unsaturation. And so there are 2 missing single bonds. So this is ethene. You've got a carbon here and a carbon here. Each carbon has a double bond and 2 bonds to hydrogen. So 1, 2, 3, 4 bonds, 1, 2, 3, 4 bonds. So carbon is quite happy. Ethene. This is propene. There's a carbon here and a carbon there and a carbon there. And so this would be 1, 2, 3 propene. And the double bond starts at carbon number 1 and goes to carbon number 2. Here is 1, 2, 3 also shown. And over here, trying to give the double bond the smallest possible number. 1, 2, 3. So there's 2 hydrogens right here that we haven't shown. There's a hydrogen there and a hydrogen there. Here's butene. So hydrogen there and a hydrogen there. This would be 1, 2, 3, 4. This would be 1 butene. Here we'd have a hydrogen hiding there and another one right there. This would be 1, 2, 3, 4. This is 2 butene. And this one hydrogen there, 2, 3, 4. This is also 2 butene. In alkanes, we didn't care very much about things like that or things like this because single bonds rotate, and so this bond could move, and if that bond moves, that would come up, which would give me that. And so it was continuously changing. This whole thing is spinning and changing, and so this is just going to be butane, and that's going to be butane. However, in a double bond, they can't rotate. So these bonds, those single bonds right there rotate, and those single bonds there rotate, but this bond doesn't rotate. And what that means is this 2-butene and this 2-butene are different. They are not the same thing. And so we have to have some way of naming these that are different. And so here's how we're going to do this. There's a couple of ways of doing this, but the most common way is to use cis and trans. So these are both 2-butenes, but they're not the same. So here we have them shown again in slightly different format, with the hydrogens being really obvious. So 1, 2, 3, 4. 1, 2, 3, 4. So the way we're going to do this is we're going to look at what's connected to each carbon. So here's the carbon and the double bond that we're worried about right there. I'm going to ask myself the question, out of these two things that are attached to this carbon double bond, which one is the biggest? And so I've got a choice of a methyl group right here or a hydrogen right there, and so the methyl group is largest. And if I look at this carbon, on the other side of the double bond, then out of those two things that are connected to it, what's the biggest one? Well, that methyl group is bigger than that hydrogen. Since the two big things are on the same side of the double bond, then this gets cis. So this is going to be cis 2-butene. And then over here, if I do the same thing, I follow the same process. I got this carbon right here. I'm going to circle the one that's the biggest, so the methyl group is bigger than the hydrogen. And then if I focus on this carbon on the double bond, then out of those two things, the biggest one is right there. And so now the two big things are on opposite sides. This is trans. So this is trans to butene. Sometimes it's easier to look at the smallest groups, and it becomes a little bit more convenient. So if I repeat this process, there's my carbon. Out of those two things that are attached to that carbon, which is the smallest, it's the hydrogen. Out of these two things, it's the hydrogen here that's the smallest. And they are on the same side, so it's cis. And over here, the smallest thing out of those two is hydrogen. The smallest two out of those things is hydrogen. The two hydrogens on opposite sides, it's trans. Now if I go back up to my 1-butene, 1, 2, 3, 4, I didn't worry about cis and trans. So let's just worry about that for a minute. I'll put my hydrogens in. So there's my hydrogen on the end, and there's my other hydrogen on the other end. So I got my hydrogens on the other end, so I'll ask myself the question, out of this carbon right here, and there's my other carbon right there. Oh, forgot the hydrogen. There's my hydrogen. So out of this and this, which is the smallest, I'm going to pick the smallest this time, well, that's the smallest. Then I go over here to this carbon. Out of these two things, which is the smallest? Well, they're identical. They're the same. There is no big or small, and so it's impossible to tell which one is going to be the biggest, which means it's impossible to tell if they're going to be on the same or opposite sides, which means there is no cis and trans for 1-butene. Well, what happens if you have multiple enes? Well, that's going to be fairly straightforward. We're going to put a hydrogen here, and a hydrogen there. And we'll put our other hydrogens in here just to be complete. And then we'll start numbering. If I go number 1, 2, then that double bond gets a 2. If I number 1, 2, then it gets the smallest number, number 1. So I'm going to go from right to left. 1, 2, 3, 4, 5, 6, 7. So this is heptene. But there's two of them, so it's heptadiene. There are two enes. One starting at carbon number 1, the other one starting at carbon number 5. 1,5-heptadiene. But let's not forget cis and trans. So if I think about cis and trans on this one, out of these two, which is the biggest one, it's a tie. So there is no cis and trans for this one. Over here, I have my two small ones are there. They're across the double bond. This is going to be trans. So this is going to be trans 1,5-heptadiene. And the trans belongs to the number 5, not the number 1. Well, down here I can do the same thing. So I got to figure out which way to start numbering. If I go 1, 2, 3, that's great. 1, 2, 3. So if I go left to right, then my double bond gets a 3. If I go right to left, then I get double bond is number 2. So again, I'm going to be going this way. So 4, 5, 6, 7, 8. This is octane, but there's 2 enes in there. So that's octadiene, octadiene. They start at carbon number 2 and number 5, 2, 5, octadiene. Now, looking for cis and trans. Again, I'll put in my hydrogens. This is going to be an example. We're looking at the smaller groups is the better. So if I look on this carbon right here, out of these two, the methyl or the hydrogen, which one is smaller? Well, that one is. Out of this hydrogen and that whole beast, then that is the smallest one, and so it's going to be trans. And then over here, I'm looking at this carbon right here. I've got that whole nastiness and a little hydrogen, so that hydrogen is the smallest one. I've got this whole nastiness, that one is the smallest one, the two small ones on the same side. So this is cis, and so it's going to be trans cis 2,5-octadiene. Okay, so write it out kind of a little bit better. We'd have trans, comma, cis dash 2,5-octadiene.